Assalamualaikum warahmatullahi wabarakatuh. Good afternoon, ladies and gentlemen. My name is Falih, and today I will present you an article about 6 key connectivity requirements of autonomous driving for this EL4126 Robotics webinar 2020. This article is taken from IEEE Spectrum and sponsored by TE Connectivity, a company that focuses on networks for autonomous vehicle. Let's begin, shall we? While the future of automotive industry is still unwritten, one thing for sure, it is going autonomous. Autonomous vehicle must be able to understand and connect and communicate with its surrounding, or in the industry, we call it vehicle to everything or V2X. It consists of vehicle to V, it consists of vehicle to vehicle or V2V, vehicle to infrastructure or V2I, vehicle to pedestrian or V2P, and vehicle to network or V2N. So in order to connect to everything, connectivity must be mastered by automotive industry leaders to manifest dreams and promises of V2X capabilities for fully autonomous driving. Autonomous driving is both an audacious visionary goal and highly achievable feat of technical engineering. The race to launch the industry's first fully autonomous car is accelerating, as technology companies like Waymo and Apple battle car companies like Audi, Ford, Tesla, and Renault, and even ride-sharing companies like Uber and Lyft to overcome technical challenge and enable an entirely new way of driving that will surprise and delight users. Who will win the race? One thing for sure, the winner is the one who masters connectivity. And here, I will explain the 6 key connectivity requirements for autonomous driving. Okay, so the first key is to have a redundant and real-time based architecture for V2X environment. This architecture will organize high-performance clusters in functional domains and be connected via a central gateway in a high-speed data backbone structure. Group sensors and actuators will be organized hierarchically. Such architecture is exemplified by this diagram. From the functional level up to the domain level, which will be data backbone, and up again to the central gateway, and then connected to the everything in the V2X environment. So the second key, the demand of high-speed data will only increase. Driverless cars will have incredibly sophisticated systems, including high-performance computers and an increasing number of advanced driver assistance systems or ADAS sensors, such as high-resolution stereo or mono camera, radar, lidar, as well as future human-machine interface, and even built-in entertainment such as 4K or 8K screens and or head-up display hoods. This system will generate vast amount of data, which will require sophisticated electronic support, including high-speed data nodes, links, cables, and assemblies. Car manufacturers will be required to continuously increase bandwidth and speed for both point-to-point data pipes and distributed network structures to meet the new data demand. Such new communication data speed is exemplified in the picture. Level 5 cars will send 25 gigabytes of data to the cloud every hour. You can see it from the diagram, from the image. The higher level performance of autonomous car will need a higher speed of connectivity. The next key is for safety and other applications that require external connectivity. V2X communication must continuously capture and interpret complete data concerning the surrounding environment. Fully autonomous vehicles require all of this information to correctly execute actions such as braking or accelerating without driver assistance. V2X communication use both radio-based data communication and embedded sensors technology. Car sensors help vehicle systems interact with their immediate surroundings, such as tree or other vehicle. Radio systems enable vehicles to exchange information with other vehicles or with traffic infrastructure such as light, signs, and tolls. Driver make decisions in split seconds and fully autonomous cars will too. So to be safe, high-speed processing sensors and real-time communication is the essential. 5G communication, which will be available for deployment in 2020, will provide higher data rates up to 10 gigabytes per second, with considerably lower latency than LTE, making it suitable for real-time safety application. Then the next key is for autonomous driving quality and reliability, which are non-negotiable. In addition to being real-time, data sensing and transmission must be 100% reliable. What does this mean is that connectivity cannot fail because of better conditions such as fog, snow, or even rainstorm for thousands and thousands of hours of operation. Vehicle manufacturers can achieve this goal by using highly robust automotive-grade connectivity system provided by competent and experienced suppliers with engineering and material science expertise. As automotive industry is growing electric too, there will be new challenge to overcome some electromagnetic interference that might happen. It is doing for our key, increasing electrified cars will require a new approach to safety. Yeah, this electromagnetic interference can or might happen and disrupt our system. Automotive companies are investigating when and where they can use optical fiber-based connectivity to avoid this phenomenon. Fiber optic communication do not experience electromagnetic emission, crosstalk, or signal distortion. This means optical communication network channel can be placed near high power electric cable, device, and provide reliable functioning without safety concern or interference worries. Suppliers are also developing in-vehicle network based on global automotive Ethernet standards, which would carry encrypted data rather than using proprietary and legacy networks where the data is vulnerable and encrypted. And the last key is the next generation car design will require miniaturized solution. To fit all this V2X system under the hood of a car, manufacturers will need to develop automotive-grade, miniaturized, and highly integrated connectivity solution. Sensors and actuators are getting smaller as links increase. The automotive Ethernet enables manufacturers to deliver both power and data over a single pair of wire, either shielded or unshielded. In-vehicle networks will need the lightest and leanest cable assemblies and connectors made yet, which will be placed in ever denser configuration. So to conclude, autonomous driving is changing the way we view vehicle and mobility. Next generation cars will not just enable transportation, they will also enhance passenger safety, comfort, and entertainment. Imagine reclining in your car as you drive, holding video conference meetings, sending emails, finishing a project before ever you arrive at work. Today, transportation is a necessary but often painful process. With fully autonomous driving, passengers will be free to accomplish their own goal, turning the dead hours of driving into fruitful hours of learning, working, engaging, and relaxing. And don't forget sleeping. Okay, that's all from me for my presentation. Any question and further discussion is welcome. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.